In this video, we will use the lower incomplete gamma function to generate the trend line and polynomial of EXPONDIST and the ERF function. We begin with the value of k, which is data validation, list of items 0.5 or 1. 0.5 if it is EXPONDIST and 1 if it is ERF. So let's generate the dataset of the EXPONDIST. So array formula EXPONDIST of the x values, where our lambda is equal to 1 and 1, the type is cumulative distribution function, and the ERF. So array formula ERF of the x values, and we chart this. We insert chart and we'll use scatter chart. Row 1 as header, column is header, and show the trend line polynomial to the 6th degree. For the label, use the equation and the legend position at the bottom. For the vertical axis, number format, none. So here's our trend line and polynomial. Next, we modify our functions. Let's modify the ERF. That's square root of x. So this will be square root of x and multiplied by square root of pi. So this, we multiplied this by square root of pi times square root of pi. So we have this ERF and the EXPONDIST. Now we generate the lower incomplete gamma function, which is the summation of a times x to the power k plus n, where k is 0.5 or 1, while a is negative 1 to the power n over n factorial times n plus k. And our value of n will be from 0 to infinity. In this case, 16 is still good enough. And we generate the coefficient. So array formula minus 1 raised to the power n divided by, there are two parts, factorial n. And the second part, the quantity n plus k. N plus k. Then enter. So this is our expansion coefficients. Now we continue with the series sum, which is equal to array formula series sum of the x values raised to the power k plus n, where k plus n starts from k incremented by n, and n starts from 0, 1, 2, 3, so the increment here is 1. And the coefficient, it will be this range, the value of a. And we modify. We have a green data set, so we change the yellow to green. So edit chart, series, this will be green. We change this to green. And trend line polynomial to the 6th degree and show the equation as labeled. And we modify all series, the point size maximum, except for the expansion, point size will be none, but the line thickness will be maximum. We'll max out the line thickness. Here's the trend line and polynomial of the EXPONDIST and the ERF. Next, we continue with the expansion coefficients. So we calculate this starting with the LINEST matrix, which is transpose 0, 2, 6. And the elements of the matrix, which is array formula of the x values raised to the power 0 to 6. And the polynomial regression coefficients, starting with the EXPONDIST, LINEST, data y, and data x. And expansion, LINEST, data y, and data x. And finally, the ERF function, LINEST, data y, and data x. So let's compare. We can toggle the value of k from -1 to +1, and our expansion coefficient approximates the blue, the EXPONDIST, at k equals 0.5. Our expansion coefficients, this is the green, it approximates the green, which is the error function. Let's check the coefficients. 0 for x to the 0, this is 0, times 10 to the minus 33, times 10 to the minus 32, that's already 0. And coefficient of x, 0.999, 4.66, 4.66. Coefficient of x squared, 0.497, negative 6.614, negative 6.614. Coefficient of x cubed, 0.16, 5.36, 5.36. Coefficient of x to the fourth, minus 0.0356, 2.42, 2.42. So negative 2.42 as well. And coefficient of x to the fifth, 4.99 times 10 to the minus 3, 0.564, and 0.564. Coefficient of x to the sixth, 3.33 times 10 to the minus 4, 0.0528, and 0.0528. We can change this to 1, and this toggles to 1. So this completes the use of array formula, LINEST polynomial regression, Taylor-Maclaurin series sum to generate the trend line of EXPONDIST and the error function, or ERF.